Hello, tonight our lesson is on the surface area of cylinders. So let's start by looking at this picture that shows how a cylinder can be made. If we start with a rectangle and we start rolling it, you can do this with a piece of paper, and you roll it up, you will get a cylinder shape. Now notice a couple things. First of all, notice that the cylinder has two circular faces, here and here, and they're both identical in size. Second, notice that the curved part of our cylinder, if we were to unwind it, the curved part would equal the area of the rectangle that we started with. All right, so if I only rolled that so that I would have just one cylinder without the paper overlapping, that's the area of the curved surface. It's really a rectangle. All right, so that's how a cylinder is made. And when we find the surface area of a cylinder, we are going to account for those two circular faces, and then we are going to account for that rectangle. All right, so here again we have a cylinder, this soup can. Notice that the cylinder has a height, and then the circular face, it doesn't matter which one you use, they both have the same radius, the same R right there. And again, if we were to snip this can and then lay it out flat, it would make a rectangle. And then notice that our rectangle, that the height of the rectangle is the same as the height of the cylinder. But then notice that the length of our rectangle is equal to the circumference of our circular face. Okay, that circumference right there is going to equal this distance. Oops, my arm slipped a little bit. That distance right there. And this is the formula for circumference, 2 times pi times r. Now that's really the same as pi times diameter, because 2 times r is equal to diameter. All right, so that will help us understand then where this surface area formula comes from. So here we have the areas of the top and the bottom circles. We have 2 times pi times radius squared. Okay, so each of those circles is pi times radius squared, and since there's 2 of them, we have to multiply by 2. So that accounts for this portion of our equation. Okay, this represents the area of the circles. Now the area of the rectangular part right here is going to be h times, and there's that 2 pi r, or you can also use pi times d. That's where that comes from. That's this area right here. All right, so let's do this example. Let's start with our formula. Okay, so the area formula, or surface area, I should say, surface area formula for our cylinder is going to equal 2 times pi times radius squared plus, okay, we have h times, instead of 2 pi r, I'm going to use pi times diameter. Again, this is the area of the two circle faces, and this is the area of that curved part, which would be a rectangle if we were to stretch it out. Now let's substitute what we know. And I'm going to save pi for the very end. So I'm going to leave 2 and pi. Okay, radius squared. The radius is 5. So that's going to be 5 centimeters squared plus the height is 10 centimeters times pi, and then the diameter would be twice the radius, so that would also be 10. Okay? Now let's kind of do our order of operations and combine things together. So here I would go 5 squared first, which is 25, and I'll times that by 2. So that's going to equal 50 times pi centimeters squared. Okay? And again, I'm just leaving pi alone to the very end. Over on the next part, I have 10 times 10. I'll go ahead and do that. That's 100. I still have the pi, and it's going to be centimeters squared. Next, I'm going to add these two numbers together, and I'm going to treat pi as if it was a variable, even though it's not. It's a constant. I'm going to add 50 pi plus 100 pi. Well, those are like terms, so I can add those together and write it as 150 pi. And our units are centimeters squared. See that? I just added them like terms. 50x plus 100x is 150x. So 50 pi plus 100 pi is 150 pi. Now I'm going to break out the value of pi, because this is the very last step. I'm going to take 150 and then I'll multiply by 3.14, because that's what we're going to use for our value of pi. All right, so get your calculator, go 150 times 3.14. And that comes out to be 471 square centimeters. And that's it. Okay, now that can look a little intimidating when you see that big formula and you see all these numbers, but if you break it down step by step and just take your time, it's not really that difficult. You should be able to do this. All right, let's try another one. All right, let's start with our formula. Okay, surface area is going to equal 2 times pi times radius squared plus the height times pi times diameter. Let's substitute. Again, I'm saving pi to the very end. The radius is 6. So we're going to square the 6. The height is 9. And the diameter would be 6 times 2, which is 12. All right, square 6 first. 6 squared is 36. Times that by 2. So this part equals 72 pi. We have square feet this time. And then over here, 9 times 12, that's 108 pi square feet. Now let's add the two terms together. 72 pi plus 108 pi equals 180 pi feet squared, or square feet. All right, now break out the calculator. Let's go 180 times 3.14. That equals 565.2 square feet. All right, that's not so bad, huh? Look at that, it just popped out of nowhere. All right, let's calculate the surface area for this one. Pause your video. Go ahead, you get out that equation, write it down, substitute for the variables, what you know, and then when you're finished, restart your video to check your answer. Welcome back from pausing the video. Here's our formula, 2 pi r squared plus h times pi times diameter. Let's substitute for the radius, which is 4. The height is 12, and the diameter is 8. They didn't give us the units for this one, so we'll just, at the end, let's say units squared. So that's why I didn't put any units with the numbers. All right, so 4 squared is 16, and then 16 times 2 is 32. So we get 32 pi for the circle faces, and then 12 times 8 is 96. So 96 pi is the curved surface. Let's add the two together. 32 plus 96 is 128 pi. And now let's multiply by 3.14. So we get 401.92 units squared. So how'd you do? All right, that's all for tonight. Thanks for listening.